Okay, I'm going to go through the solution to this problem so that you have a good reference to study from. So we have this velocity time graph, and we want to be able to draw the correct position time graph and acceleration time graph. Now, displacement over here, you can say position because your position is generated based on your displacements. So like I said before, the first thing we want to do is identify the different shapes, okay, and time segments. So here's 0 and 0 time, and it goes to, so here's the x-axis, it goes to 4 seconds. So this is our first shape and first time segment above and below the x-axis, right? So we want shapes above and below the x-axis. So that's 0 to 4 seconds, right? Now the next shape that we're dealing with goes to 8 seconds. It's another triangle. This triangle is below the x-axis, so that's a negative displacement. This other one over here, this one above the x-axis, that's a positive displacement. This is a negative displacement. Right, so now that time interval is 4 to 8 seconds. Right, the next time interval is 8 to 12 seconds, and that is a rectangle. Again, that's below the x-axis, so that's going to be a negative displacement. Right, so that's 8 to 12 seconds. The next time interval is 12 to 16, and that is a triangle. Right, 12 to 16 seconds. This next time interval, it's at rest because the velocity is 0 for this time interval, and that goes up to 20 seconds. So 16 to 20 seconds. And then from 20 to 24, okay, we have a triangle. And then the last one, 24 to 30, is this rectangle right here, okay? All right, so 20 to 24, and then the last one, 24 to 30. All right, so I need to calculate all the areas of these shapes. So this first shape, the base of this triangle right here, okay, the base is 4 seconds, and the height is 4, okay? So if I were to do 1/2 of 4 seconds times 4 meters per second, I would get 8 meters, okay? So we're going to say that this object, I'd have to tell you this in the problem, we're going to say that its starting position is 0, okay? So now the first displacement from 0 to 4 seconds, okay, based on the calculation of this area, is 8 meters, right? Now remember, the distance traveled is just the absolute value of your displacement. So this is 8, the distance traveled would be 8. Now, if I want to calculate the slope, all right, at 4 seconds, it's at 0 meters per second, and at 0 seconds, it was at 4. So as far as slope goes, the slope would be 0 minus 4 meters per second divided by 4 seconds minus 0. And so for this first slope, we end up with a negative 1 meter per second squared. Right? Now that slope continues, right, up to 8 seconds. So I know that this next time segment is also negative 1 meter per second squared. All right? All right, next. This next segment of area, if I were to calculate it, just so happens that it's 1/2 4 seconds negative 4 meters per second. So this comes out to negative 8 meters, okay? So this displacement is negative 8, and again, just make the absolute value over here for the distance change. All right? This rectangle in here, the base of the rectangle is, if I just look right here, the base is 1, 2, 3, 4, and the height of this rectangle is negative 4. So 4 times negative 4 is negative 16. The distance change, just make it positive. All right. The next triangle, the height of this triangle is negative 4, and its base is 1, 2, 3, 4. So 1/2 of 4 is 2 times negative 4 is going to be negative 8. So that was that triangle right there. This next segment, it's got no displacement, so 0. And the distance change in that time, 0. Okay. Now, if you want to start filling in some accelerations, so from 8 to 12 seconds, it had constant velocity. So 8 to 12 seconds, there's no acceleration if it has constant velocity. And then from 12 to 16 seconds, it has a positive acceleration. So if I did this calculation out from 12 to 16 seconds, right, the slope would be at 16 seconds, you had 0 meters per second minus, and over here at 12 seconds, it was minus 4. So minus a minus 4. And that gets divided by 16 seconds minus 12. So we get positive 4 over 4. This ends up being a positive 1 meter per second squared for this acceleration. Okay, so that's how I got that. Right, that's this slope, positive slope. Right, over here it's at rest. So from 16 to 20 seconds, there is no acceleration. And then let's do these areas first. So this base of this triangle right here, this is from 20 to 24 seconds. This is 1, 2, 3, 4. That base is 4. Its height is positive 4. So this area over here is 1/2 4 seconds times positive 4. That'll be a positive 8. So 8, 8. And then this last segment, the base of this rectangle is 1, 2, 3, 4, 5, 6, and its height is 4. So this rectangle is 6 seconds times 4 meters per second. That comes out to 24. So this last one, 24, 24. All right, as far as this slope, right, this slope is 4 meters per second minus 0 divided by 4. So that's a positive 1 meter per second squared over there. And then this is constant velocity. So that's 0 for acceleration. All right, I can total some things up. When I add all my displacements together, right? I start with 8, minus 8, minus 16, minus 8, plus 0, plus 8, plus 24. My final total displacement is 8, okay? If I add my distances together, right, I get 8 plus 8 plus 16 plus 8 plus 0 plus 8 plus 24, 72. Okay? So there's my total displacement. There's my total distance, right? We don't add up the accelerations. Now, what do we do for our positions, okay? So think about this in terms of, if this was an object, what would it be doing, right? So if I start, right, if here's my starting point, and I can see that as far as displacements go, my greatest positive displacement is 24, okay? And then my greatest in the negative is negative 16, right? So these are the directions I can move, but it starts moving in the positive, then negative. So anyways, if I wanted to kind of draw this out, right? So if this was like a person, and they're starting off at position 0, so position 0. The first movement that they make is they go from 0 and they have a positive displacement of 8, okay? So let's say that 8 is right here, okay, 8 meters. So the first thing this person does is they go to 8 meters, all right? The next displacement, the next move they make is a negative 8, right? So when they get over here, the next move they make is they turn around and they come back to 0, right? The next move from there is they do another, a negative 16, okay? Well, so now, if they're here at this point, they go 16 in this direction, okay? Then they go, the next move from 16 is another negative 8. So then you add on another negative 8. So this is negative 16, and so on. So this person is going to the right, then they go left, then they go left again, then they go left again. They don't go anywhere. Now they go right, and then they go right again. So it's like they go this way, they go this way, they go this way, like that. All right, they go nowhere, then they go this way, and then they go this way. This is what this person's doing. So to figure out the positions, the actual location at these different times, what we're going to do is we're just going to start with this position and add these displacements, okay? So when we do it like this, you can kind of keep track of it. This is the starting position. So what do we got to do? We got to do 0 plus 8 to get this location. So this number plus that is going to tell me where it is at that time. Okay? So 0 plus 8, it tells me that it's at 8. Okay, so at the end of 4 seconds, it's at 8 meters. All right? Now, for this next position, at the end of 8 seconds, where is it? So what I'm going to do here is I'm going to take this number, wherever it ended up at this first time segment. So it ended up at 8. So I'm going to do 8 plus this number. So 8 plus a negative 8 ends up at 0. Okay, so at the end of 8 seconds, that's where it is, 0. All right, started at 0 time. At the end of 4 seconds, its displacement was 8, so it ended up at 8 at the end of 4 seconds. The next displacement was negative 8, so if I ended at 8 at 4 seconds, and now my next move is negative 8, then at the end of 8 seconds, I'm at 0 again. Okay, well now the next thing. So now over here, what I'm going to do, 0 plus this displacement. So 0 plus negative 16, I end up at negative 16 at the end of 12 seconds. All right, well, what about at the end of 16 seconds? Well, I started at the end of 12. I was at negative 16. So negative 16 plus negative 8 equals negative 24. So at the end of 16 seconds, that's where I'm at. negative 24 on the position time graph or displacement time graph. All right, next, negative 24 plus 0, right? Because I'm not moving. I'm still at negative 24 at the end of 20 seconds, right? From 16 to 20 seconds, I haven't been moving, so I'm still going to be at negative 24. All right. Next, negative 24 plus 8 equals negative 16. Okay. So that's where I am at that point at the end of at 24 seconds. All right, well, one more displacement of 24 here. So now what I do, negative 16 plus 24 equals 8. So this is my last position at the end of 30 seconds, right? That's where I am, and that's these two match. All right? So this is how you figure out the individual positions. You just keep adding your displacements to see where you're at these time intervals. All right. Now that I have all this information, I need to draw my position time graph. All right. Well, it starts off right away. It's moving, but it has a negative acceleration. -1, all right? So it's moving in the positive. It has a positive velocity, but it's slowing down, right? So I have to be able to show that. I have to be able to show moving in the positive direction, but slowing down, right? So on this graph, this is 0. So I need to show that this object is moving in the positive direction, which means this way, but slowing down, right? Decelerating. Now at 4 seconds, it comes to rest. So this is the 4 seconds line right here. It comes to rest and changes direction, right? So whatever my curve is, it has to flatten out at that time to show that it comes to rest, right? Now, at the end of 4 seconds, its position or its displacement was 8 meters. So because it started at 0, it's going to end at 8. So at 4 seconds, it's got to be somewhere around there, right? That's 8. 1, 2, 3, 4 seconds. Okay? So I need to draw a line to show that. So my curve, this has to be a curve down. So this and flatten out at the top. So it's going to look something like that. Okay? And flattens out right there. All right. Next. It continues with the same rate of acceleration, -1. But at the end of 8 seconds, all right, its location, because the next displacement's -8, its location is going to be 0, right? It went up to 8, then it comes back down. It goes up. It has a positive displacement of 8, then a negative displacement of 8. So at the end of 8 seconds, it's going to be back to the origin, right? So continue. It's changing direction. Something like that, right? It doesn't have to be perfect on the test, but it has to show what's happening. So this is like the ball being thrown straight up in the air, right? If I threw the ball up in the air at 4 meters per second, gravity slows it down, but it's still moving up. It gets to the peak, comes to rest for a moment, changes direction. Now it's coming back down, but it's gaining speed in the negative direction. So that's this position time graph, all right? All right, next. So this is 8 seconds. Now from 8 to 12, so at 12 seconds, here's 12. The next displacement is -16. So it's it has come back to 0. The next displacement is -16. So the next position is going to be -16. So -16 is this line, 12 So this is where it ends up. However, this is constant velocity, right? So 12, 16, that's this. So from here to here, it moves with a constant velocity, all right? Now, if I found this slope, okay, this slope should equal -4, right? So if I were to take position time graph and I take the slope of this line, it should give me the constant velocity during that time interval. And if I did that, -16 minus 0 divided by 4 seconds is -4. So that matches up. Okay, let's continue with the graph. All right, so now we're at -16. This is the end of 12 seconds. The next displacement is a -8 displacement. However, it's a positive acceleration, so it's slowing down, right? It's still moving in the negative direction, but slowing down, okay? So -16 plus a -8, it ends up at -24. So at 16 seconds, which is right here, it's going to be at -24, which is right here, okay? And it's, if we look at this, that's this part of the graph, right? So it's still moving in the negative direction, but it's slowing down, and it comes to rest. So what that means is the last part of this curve needs to flatten out at that point, right? Now this has to be a curve up because it's positive acceleration. So that means it's going to look, right? If I were to draw that like this, just so you can see it, that would look, a curve up means it's going to look like this, right? And it flattens out at that point. So let me draw that. Okay. All right. Curve up. All right, now here, if I look at this graph, it doesn't change direction yet, right? It's come to rest. This is constant velocity at rest, which means whatever position it's at, it's going to stay there for a little while. And I can see that from this graph, right? -16 plus -8 gives me -24. Then from 16 to 20, there is no velocity, there is no acceleration. So -24 plus 0, -24. So at the end of 20 seconds, it's still at that same place. So what that means is this segment looks like this, right? It's not going anywhere. It stays at -24. Now what does it do? Maybe it could have come backwards, but it does accelerate in the positive direction. Okay, so now I have another curve up. And where does it end up? So +1, right? -24 plus 8, it ends up at -16. Okay, so it ends up back here at this height. Right? Now that's at 24 seconds. So 24, it's going to be over here. Right? And I have to have a curve up. Okay, so there's my curve up, a little bit better than this one. You can see the curve. All right. All right, next. So this is 24 seconds. The last segment from 24 to 30, right? It ends up at -16 plus 24. It ends up at 8, +8. Okay, so I got to look at my graph. Right? This is constant velocity, no acceleration. Right? So +8 is all the way up here. Right? So I indicate positive constant velocity. There's my positive slope. Right? So this is basically showing me what's happening and giving me the correct locations for things. Right? Negative acceleration, slows down, comes to rest, changes direction, still has negative acceleration, brings it back to the origin, has constant velocity for the origin, brings it to -16 displacement, then it slows down, right, comes to rest over here, right, at negative 24, stays at negative 24 for a little while, then has positive acceleration, all right, and it moves it to negative 16 with the positive acceleration, and then from negative 16, constant velocity for the rest of the trip, and brings it to positive 8, all right? So those are your taking, this information and graphing it and showing the correct, accelerations and segments that have constant velocity, okay? The last thing is to make your acceleration and time graph. So my greatest acceleration positive is positive 1. My greatest negative is negative 1. So I can just say that's 0. And let's do 1, 2, 3, 4. Let's make that negative 1. And let's go up 1, 2, 3, 4. And that's positive 1. So from 0 to 8 seconds, it has a negative 1. So here's 8. So there's my negative 1. Right. Then from 8 to 12 seconds, it has no acceleration. So that's this. Okay. And then from 12 to 16, it has a positive 1. So that's this, positive 1. Okay, and then from 16 to 20, there is no acceleration. So that's this. No acceleration. And then 20 to 24, it has a positive 1. So 20 to 24, positive 1. That's that. And then the last segment, it's constant velocity, so there's no acceleration for the rest of the trip. There you go. All right. So that's this entire problem from start to finish, showing you how I got all the different parts.